Hi guys, welcome to the second test corrections video. This video is going to cover all of section 1 part B, which is the multiple choice section that you are allowed to use a calculator for. Just to review the instructions really quickly, you should have your test corrections graphic organizer out. On this graphic organizer, you're going to copy the test correction and work it out. You're going to do the example that I provide, and then you're going to make up your own. After you make up your own, which looks identical to these, you're going to copy it in pen onto one of the sheets that looks like this. You're just going to put it in one of the boxes. Don't answer the question, just write it out really neatly so that I can photocopy it for your peers. If you are ready, we'll just get started with question number 9. Question number 9 says, what are the asymptotes? And then it gives you this rational function. It has a binomial over a trinomial. Right here you can see the algebraic work that I did, and I just recognized that there was a hole, and then a term on the bottom causes an asymptote. If you remember this and can do this really quickly, then that's probably the quickest way to answer the question. But this is the calculator section of the test. You should be using your calculator. You know exactly what an asymptote looks like, so why not just graph this? If you take your calculator out, go to y equals. Type in the function just like I have. If you are using a TI-83, make sure that you have parentheses. That's probably the most common mistake. You need them around the binomial on top and around the entire trinomial on the bottom. When we press graph, this is what the graph looks like. Notice that there's this weird straight line here, but you should remember that the calculator really sucks at doing asymptotes, so that's just what's going on. This makes it very easy to see there's a horizontal asymptote at 0, and a vertical asymptote at 3. You could also use the trace button if you weren't really sure where these asymptotes were. By tracing back and forth, you can see the little button move and get a sense for what numbers we're talking about. Here's one for you to do that's similar. And the correct answer is going to be C. And I just got this by graphing it on the calculator. So here's the function, and then when I pressed graph, this is what it's going to look like. I know that it's kind of dark on the screen here. Okay, and you can compare that to the different answer choices if that helps looking at them. Notice the difference between C and D is that they just have vertical and horizontal switch, so make sure that you know those terms. Great, let's move on to the next test question, which is question number 10. Question 10 says, which of the following functions is symmetric with respect to the y-axis? My first step for this would be to sketch the ones that I know. I know that sine of x looks like this. That's not symmetric with respect to the y-axis. I also know that the reciprocal function looks like this, not symmetric. I'm not sure about cotangent, about x squared, and about cos of x over x. So I'm going to graph each of those in my graphing calculator and just look at their graphs. The correct answer is that A is the only one. Of course, make sure that you use parentheses and everything for the other ones. Here's one for you to work out in pretty much the same manner. Great, the correct answer was C again, and I just got that by graphing. Here's the equation in the graphing calculator, and then here's what the graph looked like, and you can see that it is symmetric. Next question. Number 11. This is asking for the limit as x approaches square root of 2. There is an algebraic way to work this out that would involve factoring the bottom, but for weird numbers like square root of 2 and on the calculator section of the test, you really must use your calculator to do this. It's just quickest and you will feel really confident in your answer. So go ahead and type in this function into your calculator, just like I have, and take a look at the graph. The graph's a mess. Clearly there are some asymptotes here and some different things. Normally when I use the graph, I would find the A value, and then I would look at what are the Y values. But there's a problem here because I don't know what the square root of 2 is. It's a decimal. And so I can't exactly look for it here. Now, sure, you could actually go take the square root of 2. You have a square root button on your calculator. It's right here. And you would realize that it's approximately 1.4. But even then, I can't see the answer accurately enough on the graph. So instead of using the graph, for this problem you should use the table. Remember, the table is second graph and it looks like this. And I can use this to look at numbers close to the square root of 2. Now there's a couple beautiful things I'm going to show you here. First of all, you can type the square root of 2 directly into x. If you use that square root button, second x squared, and then I put 2 in, it's going to plug in the actual decimal. Now 1.142 isn't the exact decimal. Technically, it's this long number, and your calculator knows what it is, even though it can't show the whole thing. Now, we've grown to expect this. There's something weird going on. What I really would like to do is type in numbers a little bit higher and a little bit lower than this number. You could do that manually. Think of a number line. Think of some numbers that are smaller than this and some numbers that are higher than this. You could also do this using your calculator, so let me show you a shortcut, although you know enough to do this just on your own. The shortcut is to get your calculator to automatically put those numbers in. You do it by going to table set right here, second table set. And normally we just have the table ask us what the x values should be. But if you come down here and set it to automatically generate the x values, and then you want to tell it to start at the number that you care about. So I'm going to clear this out, and I'm going to type in the square root of 2, because that's the number that I want it to start at. And then I want it to go in really, really small increments. So I'm going to change this to 0.001. So I'm getting just a tiny bit closer and closer and closer. Now let's go back to the table. All of a sudden, we get a table that's got a bunch of decimal values that are pretty close to the value we want. Now, right now, my actual value is at the top, and I can only see numbers that are less than it. If you use the arrow button and scroll up, though, you can see what happens on the other side. Look at the table. As I approach the square root of 2 from the right, greater than values, I get closer and closer and closer. What's happening to the y values? Right, they're getting super negative. Whereas on the top, if you keep scrolling, as I come closer and closer and closer to the square root of 2, the y values are getting closer and closer to positive infinity. This is why the limit doesn't exist, because there's two different things happening on either side of the square root of 2. Try this next one, see if you can use the trick that I just showed you. So the answer is E, as you probably imagined. Maybe what's more interesting is how we got there. If you look back at this question, you should have typed it into your calculator looking like that. We're going to go straight to the table because you remember the strategy here. Just make sure that your table is set up correctly. So this time you want them both automatically generating. And this number comes from taking the square root of 3. So you need to do second and x squared and then 3. And it'll give you that starting point. You may have already had this one set up. When I look at the table, it starts me out with the square root of 3 at the top. And I notice coming from the right, the values of y are getting larger. And coming from the left on the other side, the values appear to be getting a lot more negative. Since the limit on either side is different, this limit doesn't exist, and my answer is E. Let's move on. Back to the test. We're now on question 12. Right, so 12 is one where I really do think the algebra is quicker than the calculator. If you see right away that you can factor this, you'll recognize that positive 4 is a whole for this function, and negative 4 is an asymptote, right? Because asymptote's when the factor is only on the bottom. If you plug in negative 4, you'll get tiny little values, which make the whole thing blow up and turn into infinity. If you see this, then it's easy to say, okay, A is true, infinite discontinuity, that's what an asymptote is. And C is true because a whole is a removable discontinuity. Now, you could have done it in your calculator. You need to be a little careful. So you put your function in, and then you graph it. And you can see the asymptote, so the infinite discontinuity is right there. The problem is that your calculator is not really good at warning you about removable discontinuities. So if you had just looked at this really quickly, you might have accidentally only chosen A. In order to see the removable discontinuity, what I would recommend is I would recommend second calc and then calculate the value, because you're kind of checking what's the y value, and you're going to check positive 4, and that's just from reading your answer choices. We're wondering what happens at 4. So when I type in x equals 4 and hit enter, what I notice is that there's no y value. That means there's a hole. That means there's nothing going on. You can see over here at 4, it looks like we're somewhere near 0, but the actual function doesn't have a y value at 4, which is why it's a removable discontinuity. Just for fun, if we typed in -4, whoops, I did that wrong, calc value, and then I want to type in -4 right here, you would get the same thing. There's no y value for -4, and you would just then confirm on the graph, oh, that's because it's an asymptote. So you need to kind of use your reasoning skills. Try it out. You can use any method you like. I'd like to make one last plug for the algebra. Try the algebra. It's quick. Do this one. Okay, so the correct answer is just B, not B and C, just B. Here's what the algebra looks like. I've factored the top and the bottom. When you have factors that cancel, it gives you a whole at, and remember to flip the sign, because what we're really doing is using the zero product property and solving for x. Can't plug in a -1 because there's a hole. Can't plug in a +1 because it's an asymptote. And then you can just kind of compare it to your answer choices here, and it should be obvious that B is the only true one. On we go. Question 13. So this is the infamous domain and range. We've been struggling with this since Unit 1. Please, 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 if you haven't already, check out the help videos on the website. I'm going to do a little bit here, but you really need to just learn it and practice it. Okay, how did I work this out? We're trying to figure out where it's going to be continuous. Remember, a continuous function can be divided or composed or taken the square root of, and it gives you another continuous function that is continuous on its domain. So this question is really kind of just a tricky way of saying, what is the domain of g of f of x? So I composed my functions. I took the g function to start with, and in where x is, I opened up the parentheses and plugged in f of x in both of those spots. When I simplify this, there's really nothing I can do to simplify it on the bottom. Now I think about domain rules. I know that the rule for domain is that you can't have a negative inside of a square root. So I wrote this expression right here to say that the bottom here has to be positive. And you also can't have 0 on the bottom of a fraction. So I'm going to have to treat these two rules separately. First of all, let's think about 0 on the bottom. If I was going to get 0 on the bottom of this fraction, that would mean that the square root of 3x squared plus 2 plus 1 would equal 0. The only way that could happen is if the square root value was -1, and then -1 plus 1 would be 0. So I know that the square root of this is not allowed to equal -1. Okay, but guess what? Square roots are always positive. So I don't have to worry. There's no way that this could equal -1, which means that there's no domain restrictions when we consider that rule. When we consider the other rule, the rule that the inside of the square root has to be positive, I have to think about, is there any way that this could be negative that would cause a problem? Well, no. When you square a number, it's always positive, which means that the answer to this 3x squared plus 2 is always positive, no matter what I plug in, which means that whatever's inside the square root in this function is always positive, which means there are no domain restrictions. In other words, the domain is all real numbers. And since the domain is all real numbers, the composition of the functions is going to be continuous on its domain. Lots of steps. Try this one. Perfect. The answer here is E, as you can see. Here's the work that I did out. Take a moment to just check it with the rules. I'm going to try and squeeze the last question in, so if you need more time, press pause, otherwise we're moving on. Question 14 is one that you should do in your calculator using the table function. Here's how I'd set it up. Type in the equation, set up your table to start at -1 and to be automatic. Look in the table at the greater than side. The numbers are going to infinity. Try one on your own. The answer should be D. Here's what your table looks like. Remember that you're on the less than side, so you're looking